Hello everyone, today we will try to solve some examples for arithmetic progression. Okay, so let us start with our first example. We have which term of AP, the AP is this 21, 18, 15 is minus 81. Okay, let us see. So we have been given AP as this. So what do we have as our first term? A is equal to 21. Now let's find the common difference D. D will be, you just take the two terms and subtract it. So 18 minus 21, 18 minus 21 will be equal to minus 3. So we have our first term, we have our common difference D. Now we need to find which term of AP is minus 81. So let's say minus 81 is some nth term of this AP. So we need to find that n. So let us write the general form of the nth term. So what do we have? The general term we saw in our last lecture, Tn is equal to a plus n minus 1 times t. As you practice more, you write this formula again and again, and it will get into your mind. And one more thing to just keep in mind, how do we write this formula, is that we are adding this d. So every time in an AP we go from one term to the next, the d gets added. So by the time we reach the nth term, the d gets added to the first term n minus 1 times. That is, we start from 21, let's say we reach 15. So by the time we reach the third term, the common difference, that is minus 3, gets added to 21 two times. So it is 21, 18 and then 15. So by the time we reach the nth term, the common difference gets added n minus 1 times to the first term. So this is one way to keep this thing in mind. Okay, so now we simply substitute the values. So we have n as Tn as minus 81. So Tn as minus 81 and A is equal to 21 plus n minus 1 times minus 3. Okay, so let's take 21 to the other side. Minus 81 minus 21 will be 80, 100, 101, 102. So minus 102 is equal to n minus 1 times minus 3. Therefore we have n minus 1 is equal to minus 102 by minus 3. And if we divide this, then we get this as 34. 9, 10. Okay, so therefore we have n is equal to 34 plus 1, 35. Therefore the 35th term of this AP is minus 81. We can also check this. So T35 is equal to A, that is 21 plus n minus 1, 34 times minus 3. This will be equal to 21 minus 102, which is equal to minus 81. So therefore we have our 35th term as minus 81. Now there is also one more question. Also, is any term 0? Okay, so let's say the nth term is 0, and then we will try to find that n. Let us write the formula again. Tn is equal to a plus n minus 1 times t. We have Tn as 0, a is 21 plus n minus 1 times minus 3. Therefore if we take 21 to the other side, we have n minus 1 is equal to minus 21 divided by minus 3, and we have 7. Therefore n is equal to 8. So what do we have? We have our 35th term as minus 81, and yes, 0 is also a term in this AP, and 0 is the 8th term of this AP. Let me quickly write what we concluded here is 35th term is minus 81 and the 8th term is 0. Let us have a look at another example. What does it say? Determine the arithmetic progression whose third term is 5 and seventh term is 9. Okay. So in order to determine the AP, we need to find the first term and common difference. That would be sufficient. So we start by writing the general formula. Tn is equal to a plus n minus 1 times t. So what do we have? The third term. The third term will be equal to a plus 3 minus 1 times d. This will imply the third term is 5. Therefore 5 is equal to a plus 2d. Or we have our first equation as a plus 2d minus 5 is equal to 0. So this is our first equation. Similarly, let us see what is next. 7 term is 9. So t7 is a plus 7 minus 1 times d. Or t7 is 9. So we have a plus 6d as 9. Therefore we have our second equation, a plus 6d minus 9 is equal to 0. In our previous chapter we had seen how to solve a pair of linear equation. So here simply we have this term, so we subtract one equation from the other. So when we subtract, we have this as minus, this as minus, this as plus. And yeah, this gets cancelled out, so we have minus 4d, 9 minus 5, 4 is equal to 0. Therefore 4d is equal to 4 and d is equal to 1. And now we substitute d back into equation 1 and we have a as 5 minus 2d, or 5 minus 2 is equal to 3. Therefore we have got our AP. So how do we write an AP? A plus d, a plus 2d, and so on. So we have 3 plus 1 is 4, 4 again you add 1, you will get 5, 3 4 5 6 7 8 9 and so on. So you can also check that the third term is 5 and the 1 2 3 4 5 6 7th term is 9. So this is our AP. Let us try solving another example. So we have our AP here as 5 11 17 23 and so on, and we need to determine if 301 is a term in this AP. So what do we do? Again we start with a as 5, d 11 minus 5 6, d as 11 minus 5 6, and we write the general term tn as a plus n minus 1 times d. So we assume this 301 to be the nth term and we try to find the value for n. So we have 301 is equal to 5 plus n minus 1 times d. So what do we have? 301 minus 5, that is 296. 296 divided by 6 is equal to n minus 1. This will be 2 3 is 6 and 2 148 times 196. So n will be equal to 148 by 3 plus 1, or this will be equal to 151 by 3. So according to this, 301 should be 151 by 3 integer, a 3 term, but there is no 151 by 3 term, right? N has to be integer. So we have first term, second term, third term, fourth term, fifth term, sixth term, seventh term, and so on. So this n here is always an integer. Either it is the first term, second term, third term, fourth term, something like that. So since n is not an integer, this is not equal to integer. Therefore, this implies that this 301 is not a term in AP, in the given AP 5, 11, 17, 23 and so on. If you keep on writing this AP, you will not find 301 in this. Let us solve one more example. Okay, so what does it say? How many 2-digit numbers are divisible by 3? So the first 2-digit number that is divisible by 3 is 12. The second is 15. The third is 18, and so on up to the highest 2-digit number that is divisible by 3 is 99. We know this. Okay, so we need to just find how many terms are there in this AP. So we need we know the first term, we know the common difference, we know the last term. We just need to find the value of n, how many terms are there. So we have A as 12, D as 15 minus 12 is equal to 3, and we have our last term as 99. So we just need to find which term is the last term. So we write Tn as A plus n minus 1 times D. So let's take our last term here. So last term is 99. So we have 12 plus n minus 1 times 3. Or this is equal to 99 equal to 12 plus 3n minus 3, or 99 is equal to 9 plus 3n, or 3n is equal to 99 minus 9, that is 90. So we have n is equal to 30. So what do we have here? So we have 99 as our 38th term, 30 term in this AP. So therefore there are 30 two-digit numbers. There are 30 two-digit numbers divisible by 3. 32 digit numbers divisible by 3. Let us quickly review what we did here. So we needed to find how many two-digit numbers are divisible by 3. So we just started to write the numbers that are divisible by 3. So we have 12, 15, 18 and so on. And the highest number would be 99. So now we just need to find which term of this AP is 99. This is our last term, and if we find that, then that n is our answer. So we placed 99 here and then found the value of n. You can find all the lectures on arithmetic progression in this playlist here, and also the lectures on pair of linear equations in two variables in this playlist here. Also, please subscribe to the channel and share it among your friends. Thank you.